Hi, I'm Jean-Paul Smets. I'm the CEO of Rapid.Space, a Europe-based edge cloud provider, which is also a 5G infrastructure vendor. Rapid.Space is a joint venture between Nexedi and Amarisoft. Nexedi, the creator of edge computing, Amarisoft, the creator of 5G virtual radio access network. Together, Rapid.Space, Nexedi and Amarisoft have more than 1,200 customers, such as listed companies in Canada, France, Germany, Italy, Japan, United Kingdom, United States, Sweden, etc. Today, I'd like to talk about digital resiliency and how to mitigate the risks that our countries are facing. Our world is becoming increasingly in a state of disorder, and we are depending also increasingly on smartphones and cloud. The first risk, which is quite obvious, is the legal and political risk. For example, WeChat got banned in the United States. Google Analytics is actually illegal in the European Union because it goes against European privacy laws. And we saw, for example, LinkedIn banned in Russia even before the Ukraine war. Those risks are sometimes called by digital philosopher Tariq Krim the splinternet. But we have now even worse risks that are already happening, risks that can destroy our digital infrastructure. For example, we highly depend on submarine cables for the internet, but those cables was, for example, cut last October in the south of France and in November in Egypt. And after the cables were cut, what happened is what we see here. No more internet access, no more cloud, no more applications hosted on the cloud, no more WeChat, no more Google Maps, no more Wikipedia, no more Line, no more everything we need to run the country. A country which depends on the cloud of another country will surely face a high risk and guaranteed chaos if its digital infrastructure are destroyed. One type of digital infrastructure we seldom think about is the 4G, 5G core network. Every 4G or 5G network has a central point of failure called the core network. This core network, if it is destroyed, as it happened in 2012 with the 26 million customers of Orange, the largest 4G, 5G telecom operator in France, well, nobody can call, nobody can get data, and it happened during 13 hours that time. One of the problems is that core networks are not replicated, and even if they are in one or two sites, the disaster recovery plans are poorly tested, if not never tested. Moreover, destroying 3 sites is not such a difficult military target. If we want to put down a country, well, we just need to destroy the 3 sites with the core networks. What we see with core network in telecom has an equivalent in the case of cloud computing called the central panel or the central OSS/BSS, Operation Support System, Business Support System. It happened, for example, in the case of Azure during 6 hours when all virtual machines got actually impossible to delete, modify or create in 2021. The central panel was no longer operational. And this problem of lack of operationality also happens to national clouds. Even if you don't depend on submarine cables, still, the central panel of the cloud, which is not very much replicated, could be destroyed, just like the core network. Destroying 3 sites is a realistic military target. Another problem that has been observed also in 2021 is Amazon Web Service, which had all its network put down by a glitch in one of its components that had ripple effect and then that span all over the whole cloud. Attacking the network of a cloud system, either through the ASIC or the network operating system or through a BGP worm, is something that is feasible. And once one element has been attacked, we often see a kind of chain of reaction that destroys the whole network. Of course, we shouldn't ignore the risk of Windows. Sadly, countries that use Windows actually are facing the risk of ransomware, as we have seen last year in many hospitals that got completely blocked with severe consequences on patients. Imagine your country running Windows on the desktop with ransomware shutting all the desktop at the same time. This could be, at the start of a war, a terrible situation. One problem we see also with cloud is that they rely on very few data centers. A national cloud has only 2 or 3 data centers. Facebook doesn't have more than 11 data centers. A coordinated attack on all data centers is something we shouldn't ignore. We thought, for example, that attacking skyscraper, as it happened during September 11, would be impossible. Actually, it was not. It really happened. So, we should take this as a lesson for all cloud infrastructures. Not only bombs or missiles or explosives can be used to destroy data centers, but also modern bomb technologies such as graphite bomb that spread a cloud of graphite in the air cooling system of the data center, create short circuits, and destroy the whole electronics. In summary, our societies, with their high dependence on cloud and smartphones, are facing a destruction risk of the submarine cables, of the 4G, 5G core networks, of the central panel of cloud systems, of the networking routing, of the data centers, or of the desktops running Windows. There is a need to consider a solution for that, because these are many risks. In case of war, there is close to 0% that none of them happen. In case of war, there is nearly 100% probability that we completely lose cloud and telecommunication. The European Union has already considered this issue under the idea of cybersecurity and come up with a typical solution: bureaucracy. But let's be serious. Qualifications and rules will not increase resiliency. We need something that's resilient by design, not yet additional rules that prevent innovation to access the market. In Rapid.Space, we have been working since 2008 on a technology called SlapOS. This technology was designed since day one as a distributed cloud. At that time, we were very worried that what happened to the World Trade Center during September 11 could happen to data centers running the cloud in our countries. So we designed a cloud system that, instead of hosting thousands of servers on a few data centers, can handle thousands of data centers with just a few servers in each. This is how edge computing was born. SlapOS was supported in 2010 by French government in a project called Resilience UNG. In 2014, we could fly SlapOS on a 777 airplane of Japan Airlines from Paris to Tokyo, making the first commercial flight running edge computing. And then we started to develop SlapOS for new businesses, manufacturing, drones, and recently telecom and 5G. Each application of edge computing has given us lessons how to make a more resilient system. Each of the applications of SlapOS teaches us how a country can prepare its resiliency for future attacks or wars. We first deployed SlapOS to automate the deployment of ERP in factories of Stellantis Group in Algeria for Peugeot and in Namibia for Opel. In both cases, the factory required that they should operate even in case of internet outage. For example, in Algeria, every year when students are passing the admission exams to universities, the whole internet of the whole country is being cut because the authorities don't want students to go online and search for answers for the exam. The problem is the internet is also cut in factories. Therefore, there's no other solution than running on-premise servers, and they should run even if internet is disconnected. Therefore, we deployed SlapOS on small computers in both factories. We brought the same level of automation we would have had if we had deployed it on the cloud in a data center, but with the resiliency of an on-premise server. This is what edge computing is about. During those deployments, we also had a hard lesson. Internet is broken. We needed actually also to reach the servers from outside the factory or to make copies of the data in a backup site. But very sadly, Nobody can take for granted that internet can connect a factory to another or a factory to a cloud. There are many incidents of routing that create congestion or that create simply the impossibility to interconnect two sites. It is not only between China and the rest of the world with the congestion problems at the border, it's a much more general problem that happens between France and Russia, even before Ukraine war, or between Taiwan and Vietnam, or in many other regions. We tend to think on the drawing we see here that the internet is a bit like the diagram on the left, a graph with nodes, all working, all well connected. But the real internet in our world is more like the graph on the right. Some nodes are broken, the red one, some links are congested or malfunctional, like the dotted lines, and some nodes are completely disconnected from the rest of the system. And with such a broken internet, we needed a technology to actually make all the nodes of SlapOS Edge Cloud interconnect each other. This is how Resist RE6ST was born. It's an open source software we put in every edge node that tries to find neighbors and that tries to find non-congested routes that interconnect all nodes of the edge computing. Resist is not only useful for international application, but also for national applications. In 2016, when French cloud provider OVH had a major routing issue, Rapid.Space servers hosted at OVH could survive the network outage by finding alternate routes, by circumventing congestions or broken links. Therefore, Resist is a great tool to actually ensure that the network is resilient in case of bug, in case of cyber attack, in case of natural disaster, or in case of war. The knowledge we acquired for now 14 years with edge computing in factories has been encapsulated in a Rapid.Space product called Rapid.Space Edge Pod. It is a one-use server with all connections on the front, power, networks. As soon as you start an Edge Pod, it boots and runs SlapOS, starts Resist, finds its neighbor, and forms a kind of indestructible mesh of edge nodes, all of them made of Rapid.Space Edge Pod. The Edge Pod can also be used to deploy industrial automation. We have, for example, implemented the complete OPC UA standard to automate production lines, and we run Beremy's open source programmable logical controller. A single edge pod can thus do the workloads that range from hard real-time and industrial automation to high-performance ERP. It can save itself to another edge pod in another site or on the same site. The experience we gained with industrial automation, we brought it later to a new field, drones. Rapid.Space is part of Nexedi Group. Nexedi was the first small business in Europe to be awarded a special funding by the European Commission as part of the European Defence Fund. We were asked to adapt SlapOS for drones and more precisely for swarms of autonomous drones. We thus created a novel edge architecture that reuses all the technologies that we use for industrial automation: Resist, OPC UA, SlapOS, and so on. And we are now flying drones that fly autonomously and keep on working even if they lose their connection to the ground. However, this project brought more lessons. For example, drones are lightweight. They don't have much battery. We need servers that don't take too much power, usually ARM. In our case, we use processors from ST Microelectronics running on boards from Olimex with extreme low power. And what we also learned during the project is that we need to run on low memory, 512 megabyte RAM, not 256 or 1 terabyte RAM as in big cloud servers. We also learned that we had to use other things that Intel-based or Linux-based architecture. And now, SlapOS can support ARM, Hygon, AMD, Ampere, and Fujitsu processors. can also support not only Linux, but possibly NetX, QNX, FreeBSD, and other POSIX-type operating systems. This is what a true edge operation system needs to support. I would like to conclude now with telecommunications and a product which actually encapsulates all our experience, the Open Radio Station. This product weighs 2.4 kilograms, and as you can see, it's not bigger than my smartphone. It has power and connection to the backhaul, 2 antennas, GPS. And inside it acts as a 5G base station, a 5G core network, an edge computing server, an OSS, BSS for automated operation, resist networking for resilient networking. It is the kind of ultimate resiliency device that actually any country needs to survive an attack on their digital infrastructure. The Open Radio Station actually is becoming very popular with defense forces, security and police. Combined with satellite connectivity such as Starlink, you can deploy internet over 4G or 5G in any region in the world instantly, and you get 180 megabit very easily from your smartphone. Because it has this internet connectivity, it can survive submarine cables being cut. Because it runs a local core network, it can survive the destruction of the central core network. Because the cloud panel it uses can be copied in thousands of copies without the risking of leaking password, that's because we use zero-knowledge technology, it can survive the destruction of the central cloud panel. Because it has resist networking, it can survive network attacks, congestions, and all sorts of incidents on the routing part of the network. It runs Linux, not Windows. It provides progressive web applications. It can survive, or it's actually immune to ransomware. And also, it can be distributed to any village, home, or office. The day somebody attacks a country, cuts submarine cables, attacks the central digital infrastructure, with 10,000s of open radio stations all over the country can build in a second a backup cloud and telecom network that can actually bring back cloud and telecommunication after an attack. All this is actually quite simple. We'll watch now a video made by Charlie Crumpton. He's a Rapid.Space business developer in Latin America. He was in Managua and he set up in about 3 minutes a complete 5G edge node actually in the center of the city.
So to introduce the equipment, we have the all-in-one box 4G or 5G capable here. On the outside we have Ethernet and power socket, antenna sockets and GPS. And these would be to screw into the antenna sockets, and the antennas here, waterproof Ethernet and power cable, and then power adapter. And then this here represents what would be the backhaul in this kind of system. And so later I'll begin by connecting this to my phone, which I'm recording on, in order to help the station just receive connection to begin with. We also have these two devices, which we use in the test to show video streaming and also voice message sending. So now I'll just begin by plugging everything in. So, as we can now see, the device is powered on, and I'll just cut away in order to get the pieces of user equipment established and the connection sorted. Hi, so after a couple minutes we've got everything connected. For the purposes of this demonstration we're using these two smartphones, and we use these apps called Armin in order to do this. So we can see on the team that we're connected to either device. We can also send a voice message, which might be a little bit difficult to see on this video. Hello, 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 hello. Equally, we can do a video test, which I'll do on this one. And we can stream it to this device. So we can clearly see here is the ORS on this screen. It's panning around. You can also see us. And also there. So this can be viewed either way, to either device. And as I said before, this adapter here represents the backhaul. And so currently my hotspot on my phone is being used to generate the internet. We can just demonstrate that here. These are currently connected to the internet, you can see. And so I'm now going to unplug this, which will then remove the internet connection. And we can see the devices are still able to send and receive. Hello, testing, testing. And to do the streaming test again. You can see that's now fully working on either device. So that concludes the test, and we can see that the demonstration shows a very clear and working signal, and the box itself, obviously we're in a small confined space here, but it is possible to get up to 1 to 2 kilometers on the ORS. Thanks.
What is impressive with the Open Radio Station is that it is truly plug and play. It can even be used by politicians. Charlie is actually an assistant of a UK politician previously. Setting such a 5G network has never been as easy. Another aspect of the Open Radio Station, which is also pretty interesting, is that it keeps on running even if the backhaul is down. You could see that phones can actually exchange messages whenever he disconnected the cable. This means that if you use Open Radio Station combined with satellite, and if satellites links get destroyed, as it happened in the beginning of Ukraine war, you still get something running. And because one Open Radio Station can connect to another one and form a mesh, you still have a plan B to the satellite backhaul. Also, the CPU we use is actually Intel, but it could be anything else. Hygon, AMD, Ampere. We are completely vendor independent. The Open Radio Station can resist blockades, can resist trade war, it can be produced anywhere. That's because actually the design is open source. You can download it on the internet and start producing it yourself. And you'll see, it's very easy as we see in this video. Some people call us Open RAN, but actually we are not Open RAN, we are Simple RAN. Simple RAN is very different from Open RAN. What we care is make a product which is stable, which is simple, which is cost efficient, and that empowers users to become fully autonomous with full access to source code, hardware design, and operation procedures. We rely on Amarisoft stack, which is the de facto standard for carrier-grade virtual radio access networks. Simple RAN, unlike Open RAN, is progressing very fast and for real. Already 2 Tier 1 operators have adopted it in 2022. It was also adopted increasingly by security, police and defense. Airbus, for example, won a nearly €1 billion market based on technologies of the Simple RAN ecosystem. The Open Radio Station is a kind of demonstration of what Simple RAN can be in just 2.4 kilograms. If you need digital resiliency for your country, if you want to survive submarine cables attack, if you want to survive outage of core network, destruction of the cloud panel if you want to survive Windows ransomware, attacks on the routing algorithms, or destruction of data centers, the Open Radio Station is the ultimate resiliency tool. First, use it. Produce it locally, you're allowed to. Deploy it in thousands of copies, and you get your initial resiliency. Then, because it's open source, improve it, customize it, extend it. You are free to do it because it's open source. And you'll get complete digital resiliency for your country.